Hi, I'm James Allen, the director of the Center for Intelligent Information Retrieval.
Hi, I'm Hamad Zawani, the associate director of the center.
The CIIR was started in 1992 here at UMass Amherst by Bruce Croft and colleagues, and has been one of the top research groups exploring information retrieval and related areas since then. We've produced over 1,000 refereed papers and worked with more than 100 industry and government partners on problems and solutions related to IR. We've worked with and/or trained over 400 students and have graduated about 75 PhD students. Our research has covered a huge range of IR and related topics over the years. We're currently working in a number of areas that include neural approaches to information retrieval, conversational search and recommendation, methods for modeling and detecting controversy and misinformation, explanation of search and fairness in search, cross and multilingual search, event and entity-driven search, interactive methods, and so on. We also make our software and data sets freely available for other researchers to take advantage of. We're now going to talk a little bit more about the first four of those topics, starting with Hamed giving a quick sketch of some of the work that he and his students are doing on neural approaches for IR.
CIIR has been pioneering research in neural information retrieval by developing deep learning models and optimization techniques for fundamental information retrieval tasks. With respect to efficiency and scalability, we have developed efficient models for learning sparse representations for queries and documents. Such representation would enable us to perform efficient retrieval through an inverted index data structure. This is constructed based on the sparse representations learned by the neural models. In addition, we are developing effective approximate retrieval models that can efficiently retrieve documents using dense representations learned by neural IR models. We additionally explore solutions to improve the robustness of neural models across search tasks and collections. And with bridging the gap between modalities and languages, we've been able to extend our solutions to a wide range of scenarios, including search problems in resource-lean languages. CIIR is also pioneering research on training deep neural IR models with limited labeled data. We have developed weak supervision techniques for training these models, which have revolutionized deep learning research in information retrieval. We are still pushing this direction forward by generalizing our solutions to different scenarios and tasks. Let's hear from Yenchie and Lakshmi, who work on these problems.
My current research work is generalized weak supervision on neural IR. I consider those neural models trained on unsupervised weak signals as the next weak labeler. Therefore, after training a model by weak supervision, the model can be a better weak labeler for its own or other models training next time. By this operation, we can further improve our ranking performance than original weak supervision without adding ground truth.
My research area is non-factoid question answering, specifically questions with different types of answers. My most recent research work involved using weak supervision signals with a BERT model for the task of passage similarity. This model was then used in a diversification framework to get a significantly improved rank list for these types of questions.
The CIIR is also pushing the boundaries towards developing and evaluating conversational search and recommendation models. Most devices used for conversational interactions are often based on limited bandwidth interfaces, such as a small screen or voice-only interfaces. This impacts the way that the users and the systems interact with each other, which is oftentimes in the form of natural language. An interesting and important research problem here is to develop models for mixed initiative interactions, meaning that the user and the system can initiate a conversation at any moment. With such interactions, the system can ask questions for clarifying the user's request or for eliciting the user's preferences. Let's see how Helia and Ali are solving these problems.
In search engines, users always ask a question or submit a query and the system responds. But when it comes to conversational interactions, we can go beyond such a user asks system response paradigm. My work at CIIR focuses on addressing this problem by developing conversational search systems which are capable of having mixed initiative interactions with users.
My research is focused on maximizing evaluation measure in information retrieval by reinforcement learning. At the moment, I am working on generating relevant questions for conversational product search, aiming to maximize the goal of the conversation, which is finding the target item among lots of products by asking relevant questions from users.
As you can imagine, evaluating conversational search and recommendation systems can be extremely challenging. CIIR researchers have been working on these problems to develop models that can consider both the cost and benefit of each interaction in a conversational setting, for example, through Markov decision processes. This provides theoretical and practical solutions to the problem of conversational search evaluation. We also work on handling multi-turn interactions in addition to leveraging both positive and negative feedback received from the users in a form of natural language. Our students, Chen and Keping, will tell you more about their work in this area.
In my research, we focus on a major challenge of conversational search, which is to leverage the conversation history to understand and fulfill the user's information need. We study history modeling approaches for conversational question answering from two aspects, history incorporation and history selection. Our work is one of the fundamental steps to support people's multi-turn information seeking activities on conversational interfaces.
My main research direction is to leverage user feedback in information retrieval with neural methods. Most of my work is in the scenarios of product search and information seeking conversations. Specifically, our work includes using positive feedback to find more relevant results and leveraging negative feedback to identify the first relevant results.
One of the big challenges of the sort of complex state-of-the-art neural models for information retrieval that we and others are developing is that they're often difficult to interpret. What features of documents, of the query, or of the searcher or other searchers who've issued that query in the past were used to rank one document over another? If we can figure that out, it could be used by a downstream computing process to help drive algorithms. But the explanation an algorithm can use might not help a person understand. So we're also exploring how to use it to explain to a lay user why a document was retrieved in more detail than highlighting just a simple query word in the snippets. Related to that, we've also been exploring ways to analyze the content of the ranked documents to show the user how they all relate to each other and the query, and how they're different from each other, both with respect to and independent of the query. My colleague, Negan, has been working in this space along with students Tanya and Pushwan, and they're going to talk about the work they've been doing.
Almost all search results are obtained or refined by deep neural models. But do users understand why each item is considered to be relevant? Do search results provide a full spectrum of claims, different opinions, or aspects of search queries? Do users trust search results and questions like these? So we are working on explaining search results or designing interpretable ranking models to address these questions.
As machine learning-based retrieval models are becoming larger and more powerful, they're also becoming harder to understand. Consequently, it is harder to identify artifacts in training, data-specific biases, and intents learned by these neural retrieval models. My work focuses on generating explanations for decisions made by these retrieval models. With this, we hope to increase the trust and adoption of neural models in real-world tasks.
People often need to examine multiple web pages to find exactly what they are looking for about a topic. I research for better methods to automatically organize search engine results. Specifically, I use NLP techniques to analyze the ways that relevant documents are the same or different. Then, natural language explanations are generated and directly presented to the users in order to make their searching process much more efficient.
For the past several years, I've been interested in computational models of controversy, of methods for detecting disagreement in text. How could that be used? Well, given a document or web page that talks about a topic, should a reader, say you, believe that it is definitive? Or could a tool signal that that page is talking about a topic where there is substantial disagreement elsewhere? That is, suggesting that you might want to look more broadly before assuming that page is correct. We've developed models that spot disagreement in Wikipedia, in tweets on a particular topic, and on the web in general. Parts of this work turn out to be helpful in identifying conflicting statements that lead to methods to recognize intentional disinformation or misinformation. In addition, building on some of the ideas we just talked about for explaining document relationships, we've recently started focusing on explaining how a topic is controversial, how disagreement appears, finding stances on a topic that are different, and identifying what about them is different. Toward the broader goal of serving the common good, we're further extending these ideas to identify violent or abusive content. Young Wu and Sheikh will say a little bit about what they've been doing on these fronts.
When it comes to search for information in controversial topics, people need to think what are the possible opposing stances and decide which part of the information to accept. In our research, we are developing a method to identify and retrieve the opposing stances for the controversial topics. Specifically, we are investigating the better neural topic representations that is more scalable and applicable to newly emerging topics.
I focus on understanding text from the discourse of entities and events. One of my goals is to help political scientists and journalists to find relevant events from free text to monitor the activities of important political agents, such as police. Along with my colleagues, we received a grant from Kaggle to build datasets for such problems. I'm also interested in detecting abusive contents, and I have interned at Amazon Alexa Shopping Science team and CheckStep Incorporated to build domain adaptive and limited resource content flagging systems.
In the future, we will continue working on the project we just mentioned in this presentation. We are especially investing in conversational interactions to shape the next generation of search engines and recommender systems. We are also looking into finding efficient and effective solutions for joint and end-to-end modeling of information retrieval and extraction tasks. For example, multimodal interactive search and cross-lingual matching of events. We are also working on a number of query by example problems, where we model the areas of interest based on the examples explicitly provided by the users. There are a lot of other projects related to search and recommendations that are going on in the CIIR. Not all of them fit into such a short presentation. So if you're interested in any problem related to search and recommendation, please feel free to reach out to us. Thanks for watching.